Hey class, Mr. Bean here for AP Physics. I've been asked to give a video explanation or hint on Lab 22, Newton's Laws simulation for AP Physics, and in particular simulation number 7, acceleration down the inclined plane. And notice here we also have a quick graph tool as well. So let's go ahead and get right to uh, the simulation here, and it looks like this here. And so we're going to be this car is going to be, we're going to click on the car, it's going to accelerate down this incline, it's going to hit this barrier, and it's going to give us top speed. It's also going to give us the time it takes to go from here to here. So what's not clear is that we want to collect data here on the x-axis. It's going to ask us to collect distance in millimeters and the time in seconds, and then see what kind of relationship results here. Okay. All right. So let's go and take a quick look here and start off here. So it starts from 0. And this here, I'm thinking, is that this is in millimeters. So this is 50 millimeters. This is 60, 70. So we'll use this edge right here as 70 millimeters. So I'll go ahead and put down 70 here. And we'll click on the car and see how long it takes to get down there. All right. So here it is here. Now I can't kind of see it. It's kind of make it a little bit bigger here so we can kind of see what it is. Oh man! Oh shoot! Okay, hold on. I just try it one more time. Yeah, okay, we're here. Okay, so it's 50, 60, 70. All right, and the time here looks like it's 0.215. So I'm gonna go ahead and say 0.215. If you look closely here, it's about 0.215. We may have to make this bigger to be able to see it. Okay, in case we can't see it. All right, so it says click on the car to restart it, and click on this to get to a new location. So here's our new location here, and this is 100, 110, 120, 130, about 135. So at 135 millimeters, and we'll click on the car and see what the speed is. So here's the top speed here. And it looks like exactly, we'll say about, well, we can say 0.29 seconds. It's not quite on the point 0.3. We'll say 0.29. So 0.29 seconds. Okay. Click on the car here and click on this to a new location. So the new location here looks like 150, 160. So here oh gosh, I clicked on it. Be careful, don't click on it, otherwise it'll move. So we'll have to use another one here. So this is 200, 210, 220, 225. So we'll say 225 here, and let's click on the car and see what happens. All right. And the time looks like, I'm going to say about 0.385. So 0.385 here. Okay, click on the car and let's do one more. And this looks like right at 260. So 260 millimeters. And click on the car here and see how long it takes. And it looks like, I'm going to say about not quite 0.41. We'll say 0.4 05. Okay. Now let's take a look at our graph and see if we have any kind of relationship here forming. Um, Not quite. I'm not quite sure yet, but let's try maybe couple more points here. Let's go back to here. Let's move this again. And this here is now, looks like 300, 310. This is 320. So I'm going to say about 318. We'll say 318. Click on the car here. And let's see it do its thing here. And okay, so I'm going to say zero point 0.4. This is 0.4. This is 0.45. I'm going to say about 0.46. We'll say 0.46. Okay, and let's do a couple more. Let's just do one more here. We'll click on here. The new distance here is 350, 360, 370, 380. So we'll go ahead and do 380, and we click on the car here and let's see what happens. It's rolling down the hill here, and let's see. Okay, I'm going to, well, this is about zero point 0.5. Yeah, okay, we'll say 0.5, 59. Okay. Uh, see, point 0.5, almost point 0.1, so maybe point 0.05. Okay. All right, let's take a look here and let's see what kind of relationship we have. Let's do a curve fit and let's see. Not quite linear. Let's try maybe square root. Square root seems to fit. Okay, so I like the square root here. And take a quick, yeah, if we did linear, that might, I think this is a square root function, okay, because it's accelerating. And remember, distance is equal to 1/2. Yeah, just to remember, distance is 1/2 uh, acceleration times t squared. So there's a square function here. You want to just kind of be aware of that. Um, Okay. Now, okay, how do I know it's square root? Yeah, good question. Let me go ahead and pull up a document here. Let me see. Let's go to right here, open up a document real quick. And let's open up this one here. And okay, so let's go ahead and open up let's get a pen here. All right, so we know that distance, right, is equal to we'll say here 1/2, right? Here's a t squared. Now here we have distance and we have time, right? And so we only have time in here. So distance and time relationship. So this should be a square. It looks like a square root function here. Um, okay, let me go ahead and kind of um, let's go back to all right let's go back to the lab real quick here, and let's go back to here. Okay, so let's go back to the back to mouse here. All right, mouse pointer, and let's make this back to 100 here. And this looks like a square root relationship here. Here's distance and here's time. Okay, and let's see what we got. Let's do finished here. And it's asking us create a graph with distance in millimeters on the x-axis and time in seconds on the y-axis, which we did. Okay, enter the graph constant. Okay, so let's put our name in here first. Go ahead and put in here Thanos. Now the graph constant. So this is a square root relationship. Now if we did some other points here, they would have ended up here. There's like a square root. So this is a constant right here. Okay, so we'll go ahead and put in here 0. Was it 26? Okay, probably now 0.026 right here. And now it says here, travel time needed to travel 1413 millimeters. Okay. Okay, what's the time needed? So that means, so y-axis is time. This y is time, and this is going to be distance. So we're given a distance of 1413 should go here, and we'll need to solve for y. So let me go ahead and hit pause, and I'll go ahead and do that. All right, so I did this here, and I got 0.977. Okay, that's the time needed for it to travel 1413. Okay, 1413. Okay, and distance needed for 1.92 seconds travel time. So that means that we're given y here, which is 1.92 seconds, and we got to solve for x. Okay. All right, so I did that calculation there. I got 53 millimeters. Okay. All right, let's go ahead and see if it works here. Let's go ahead and hit submit. And it says, hey, Thanos is correct. So I was close. All right, so that's how you do that. Okay.